Okay, so COP27, Conference of the Parties 27, is going on in Egypt, and India has proposed again a few things and wants to be part of the game. And this is a nice McKinsey report that just came out on decarbonizing India. So I'm just going to summarize it here briefly. It's a long report, over 200 pages, so I'm just going to pick a few nice results to show what the main points are. Looking at India's current carbon emissions mix, these are baseline emissions in million tons of CO2 equivalent for 2019. As you know, CO2 equivalent is when we convert non-CO2 greenhouse gases into CO2 using global warming potential and so on. This is emissions total of 3,274 million tons CO2 equivalent, and then there is a carbon sink shown here. Unfortunately, the sectors that dominate are still power with coal, and then agriculture for India is a big player as well at 585, and then of course there is the industry at 928 million tons CO2 equivalent. The coal phasing out is not going to be possible for India for a while because of all the constraints it faces in terms of energy security, energy independence, dependence on imports, etc. And gas and oil-based generation here is a small part of it. So this is 2019 percentage of gross emissions. Under industries, of course, iron and steel and cement dominate. There is lime, mining, refinery, and others. For agriculture, dairy, rice cultivation, India is a big rice consumer with a lot of livestock, so cows and buffaloes add methane as well. Then you have use of synthetic fertilizers, other animals, and farming equipment contributing significantly. We'll look at a bit more details on decarbonizing this in a minute. Then come transportation, water and waste, buildings, and then you have land use change, forcing, and natural climate solutions, giving you here a carbon sink of 345 million tons CO2 equivalent. So the total of subtracting from there, you have 2,929 million tons of CO2 equivalent. Okay, so what do we do with it? We look at possible pathways for India to decarbonize as provided by McKinsey report and from UNFCCC Climate Action Tracker, McKinsey India, and India's biennial updated report 3. So look at the historical context of where India is in terms of gigaton CO2 equivalent per annum. Okay, so potential to go to net zero with technological advancements, for example, improved capture technologies, newer recycling technologies, and ocean-based carbon sequestration. India is experimenting with iron fertilization, for example, but in the scenarios you can also include blue carbon, etc. So here we are by 2020 at 2.9 gigaton CO2 equivalent per annum. We end up in third or fourth place based on how you count it, especially for the European Union. And accelerated scenario peak. So the report looks at what is called line of sight scenario, exactly where you want to go in terms of just focusing on the targets into the future for decarbonizing. So there, the line of sight scenarios implementation of India's nationally determined contributions, existing and currently announced policies, technology advancement as per current trajectory, and shift in demand to sustainable alternatives in selected areas such as electric vehicles. And then there is an accelerated scenario imagined with various caveats associated with them in terms of funding and other impacts it will have on livelihoods, etc. There you have adoption of new policies such as carbon pricing, which is not doesn't exist right now. Technology breakthroughs such as carbon capture, utilization, and sequestration, and faster implementation of existing levers. So we'll look at some of these levers in a minute. Accelerated shift to sustainable consumption such as electric vehicles, alternate materials, coarse cereals, grains, green coarse cereals and green steel, etc. Okay. We'll look at the details in a minute. So you can see how the pathways end up. This is reducing emissions intensity at minus 1.3% per annum, as happened during 2010 to 2011. That would bring us here. So that's the CO2 equivalent over there, 207 gigaton CO2 by 2070 that has to be removed. And you have line of sight scenario, which takes you down to instead of 11.8 per year here, down to 1.9. These are cumulative, so this is the line of sight scenario. Accelerated scenario would have India coming down, decarbonizing by 2050 with cumulative carbon of 80 gigaton CO2 equivalent and reaching 0.4 per year and staying down there with CCUS. Obviously you would go to 0, so you can see this is there. So there are some footnotes here that I won't read, but basically it's about whether land use change forcings are included, and what the 1.5 degree C pathways are in terms of the remaining carbon emissions when we look at the cumulative emissions, which we have discussed elsewhere. Economic emission intensity reduction in India has to happen as well. So if you compare to current economic intensity of world's top emitters in kilogram CO2 equivalent per dollar per annum, Russia is up here, India is second in place, China and India are almost the same with a slight difference. Brazil is below here, US is doing very well at 0.3 kilogram CO2 equivalent per dollar per annum, but there are many details here in terms of how you count the emissions. Importing stuff from China and using in US may assign the emissions to India, to China, for example, in terms of GDP intensity and so on. Nonetheless, looking at kilogram CO2 equivalent per dollar per annum going from historic period, you have a reduction of 54% by 2020 from 3.24 kilogram CO2 equivalent per dollar per annum to 1.52 kilogram CO2 equivalent per dollar per annum. Has to go down by 98% to decarbonize from there 2020. So you have again the current policies reducing emissions at 1.3% per annum will get you here by 2070 at 0.78 kilogram CO2 equivalent. If you take the line of sight scenario, it will be down to 0.12, and accelerated scenarios by 2020 would bring us to 0.05 to 0.03 by 2070. And remembering India's stated net zero target is 2070, so that has to be kept in mind. Just looking at a few more things like emission curves for line of sight and accelerated scenarios. Look at net emissions, power sector, industries, agriculture, transport, waste, buildings, oil and gas, and carbon sink. So these are sectoral greenhouse gas emissions in the line of sight scenario, various ways in which they have to come down with net emissions going negative obviously over time to decarbonize. And sectoral greenhouse gas emissions in the accelerated scenarios would have us drop very quickly by 2050 with much higher net negative emissions helping to remove the irreducible or positive emissions in these sectors. You can see that the power sector has to go basically to zero with renewables, whereas industry, agriculture, and the others will still have positive emissions with a net emission of 0.4 or 0.3 gigaton CO2 equivalent after 2050, being compensated by the CCUS and other negative emission technologies. What are the challenges for India's decarbonization? This is an extensive figure, so just think about power and where we have to go in terms of solar, wind, and then onshore. So there is land requirements associated with these, as we will see when we want to ramp up the power sector in terms of gigawatts. And here you have again line of sight scenario, accelerated scenario, and current situation. So you can see that a line of sight scenario would have much higher requirement for solar and wind, whereas the accelerated scenario would add additional by 2030, 2040, and 2050. Okay, refining capacity, again, various estimates here. Battery costs, dollar per kilowatt hour, have to come down. And you have land requirement for, sorry, this is average annual solar plus wind onshore capacity in gigawatts. This is land requirement for solar plus wind and onshore in terms of millions of hectares. So obviously we'll keep going up, which is not trivial in terms of how small the country is, the population, and the requirements to decarbonize in terms of space for solar and wind implementation. Coal consumption, again, here you can see in line of sight and accelerated scenarios, you will have to phase out coal very, very quickly. Then that would depend on other things like cost of green hydrogen, which has to come down in both of these line of sight and accelerated scenarios. As well as storage capacity has to go up in terms of gigawatts, both in line of sight and accelerated scenarios. Coal power generation capacity has to come down, even though projections are that India will have major dependence on coal for at least 20 years. So that's not good news in terms of decarbonization. Electrolyzer capacity for green hydrogen has to ramp up. Battery costs we mentioned, number of chargers have to go up, switch over to 100% EV sales have to happen pretty quickly in terms of two-wheelers, three-wheelers, cars, trucks, medium and heavy trucks. So by 2030, 2040 and 2060 here. So FAME subsidies extended till 2030. That's fuel efficiencies, etc. Retail fuel prices maintained 2022. Battery spot prices hovering around $180 per kilowatt hour to $195 per kilowatt hours due to geopolitical issues and COVID impact. So India will not have control on many global market forces, so that will delay things as well. Okay, so this is continuing with the challenges. Agriculture remains big emitters, and of course steel and cement, and circularity and financing have to come into picture. So as you know, we talked about circular economy elsewhere, where you don't mine things, exploit, and then bring it to production and just leave them, but you take care of the recycling, reuse, and so on. Here are electrifying of on-farm equipment, incremental land requirement for trees in millions of hectares, incremental land required for regenerative agriculture, which can be part of the nature-based climate solutions or natural climate solutions. Under steel and cement, we've talked about this elsewhere. So we have steel capacity, steel scrap-based electric arc furnace capacity, steel, hydrogen green steel capacity, cement heat demand met by green fuels, and so on. So you can see again, line of sight and accelerated scenarios require lots of kind of planning to accelerate the decarbonization by 2050. Circularity and financing includes recycling rates for plastics, recycling rates for construction and demolition, recycling rates for municipal and solid waste, average annual investments required in terms of billions for percentage of real GDP for accelerated and line of sight scenarios. Here you can see that the numbers are quite large. A lot of it is front loaded, but still even by 2050, sorry, this is an error here, not 1050, 2050, you have quite a large number of billions of dollars needed for implementing circularity and financing. More than 80% of the abatement can be achieved through 17 key levers that we mentioned before. Cumulative emission reductions between line of sight and accelerated scenarios for 2020 to 2017 gigaton CO2 equivalent cumulative emissions here with accelerated adoption of renewable energies, metal circularity, so recycling, etc., carbon capture, utilization and sequestration, sustainable farming, natural climate solutions, so managing land use and afforestation and other things, peatlands, wetlands, salt marshes, etc., all come in there, grazing practices, tillage practices, and so on. Scale up green hydrogen, faster penetration of electric vehicles into the market, other abatement levers. So cumulative emissions in the accelerated scenarios for 2020 to 2070 would be 82, whereas for line of sight it's almost double at 160 gigaton CO2 equivalent. Both line of sight and the accelerated scenarios are realistic, but would likely require substantial investments, again without going into all the details here because we don't necessarily know the uncertainties in these scenarios as we go out to outer decades. Transmission and distribution, coal, other fossils, solar and wind, other non-fossil, and storage. So you can see how they have to ramp up. So emission peaks in the early 2030s, CO2 equivalent emission then until 2050 in million tons CO2 equivalent. So you can see we have to drop off. Coal reaches net zero by 2070. So again, you have all these sectors here playing. So you will need $2.5 trillion investment required by 2050. Investments in renewable energy and storage until 2050 in billions of dollars. You can see that that's 2,500 billions, which is 2.5 trillion. Obviously, this will be part of the India's pathway towards net zero by 2070 and decarbonization. In the accelerated scenario, so this is for LOS and accelerated scenarios. Here you have non-fossil capacity at 600 gigawatts by 2030 in the accelerated scenarios, so that you can hit your decarbonization by 2050. So non-fossil capacity here. This is emission peaks in mid 2020s as opposed to early 2030s here, and coal reaches net zero by 2050 instead of 2070 in the accelerated scenario, and the investments needed would then go up from 2.5 trillion to 3.8 trillion by 2050. Okay, so obviously a tall order in terms of wanting to get there. Agriculture is one of the largest emitters of greenhouse gases in India. So where does it come from? If you look at the total we looked at before in terms of 585 million ton CO2 equivalent in 2019. Energy use, so agricultural energy use comes from oil, natural gas, electricity used in tractors and irrigation pumps. So livestock, which includes other animals, buffaloes, so ruminants, and cattle. And then India's over application of nitrogen-based fertilizers comprises 25% of global over applied nitrogen volumes, second only to China. So food security demands and in general are met by just overusing fertilizers, which has all kinds of other issues of perturbing the nitrogen cycle, water quality, air quality, soil health, etc. So you have other crops, and India's the second largest rice producer in the world. Over 80% of rice fields are estimated to practice continuous flooding, resulting in high methane emissions. We have looked at efficient rice cultivation, also newer types of accelerated growth rice types and so on, which will have to come in. But you can see here fertilizers and rice together add up to 585 million ton CO2 equivalent for 2019. CO2 abatement through natural climate solutions can be achieved below a carbon price of $50 per ton CO2 equivalent. So the accelerated scenarios must include carbon pricing. So I won't read these, but you can see the abatement potential in 2050 in accelerated scenarios versus line of sight scenarios in million ton CO2 per year. looking at agroforestry, forests and trees, and blue carbon, which is of course coastal carbon, recovering mangroves, seaweeds, subaquatic vegetation, etc., which can sequester much more carbon than land forests, and they don't burn down, and they provide protection against storms and so on. North Indian Ocean is warming, and cyclones are reported to be increasing, so this is co-benefit from blue carbon as well. Okay, so keep that in mind, and then look at a few points here. There is an opportunity for India to create 287 gigatons of carbon space for the world in terms of its role for meeting the 1.5 degrees target as well as decarbonization. While achieving the line of sight scenario reductions will be challenging, achieving those of the accelerated scenarios will be even more so. If India is to have an orderly and accelerated decarbonization, the transition has to be set up within this decade. Okay, it has to start right away. India would benefit from this. India's transition from thermal power to renewables is expected to decrease the average cost of power supply from Indian rupee 6.15 kilowatt hour 6.15 per kilowatt hour in FY22, INR 5.25 per kilowatt hour, and INR 5.4 kilowatt hour by 2050 in the line of sight and accelerated scenarios respectively. So you can see there are co-benefits of doing this. Of course, health and other externalities are not explicitly included, which will add to the co-benefits as well. There would be shifts in the energy system. The pressure on land system will increase. Land systems, sorry, I forgot to edit these things. There would be a moderate impact on household spending and jobs in terms of allocation of income for food, energy, and so on. Large funding would be needed, 3.5 to 6% of the GDP front-loaded, but substantially in the money. What are the 10 bold actions that are imagined by the McKinsey report for India to pursue? Laying out a detailed medium term, so 5 to 15 to 25 year decarbonization plan would be a bold step. Accelerating the implementation of a compliance carbon market within 3 years would be amazing. Enabling banks to support the transition catalyzed by a green transition bank. Some of this is kind of happening, but still a long way to go. Accelerating renewable adoption in the power sector. Investments made in infrastructure and continuing to be made in the coal sector are going to be a barrier to this, but this is why this is a bold action. Empowering a nodal authority to define a national land use plan would help meet the requirements for implementing solar, wind, additional land needed, and so on. Creating a resilient indigenous manufacturing capability and increasing investment in clean tech research and development. Evaluating 5 carbon capture and sequestration hubs in Gujarat, Odisha, Rajasthan, Maharashtra, and Andhra Pradesh will be a bold step. Consider creating a national circulatory mission where the recycling and reuse are going to be enhanced to reduce waste and emissions. Enhancing the national hydrogen mission and aiming to play on the front foot, like in cricket, where you don't go on the defensive and a back foot, but you face these issues head on and take offensive pose to address each of these instead of going on the back foot and being defensive. Okay, so it's just a brief summary. The long report, you can go and read it if you wish, but I hope this brief summary helps as well. Okay.